Hello class, welcome back. This tutorial will introduce the k-nearest neighbors for building classification model and also regression model. Well, we will use the IBK model for this KNN model building from the package RWECA. Well, from your machine learning with R book, they are using a different package, the KNN package. So we here use a dataset, breast cancer dataset, similar to the dataset they used in the book for your comparison. Well, we will upload the sample code from the book to your tutorial folder, but we will not go through that sample codes. You can compare them by yourself. Here we only use the IBK model from our WCAG package. So let's first import this breast cancer model, breast cancer dataset. Sorry. So this breast cancer dataset is from the UCI machine learning dataset repository. So for the structure, we can see that in total we have 32 variables and 569 patients. And the first variable is the ID, the patient's ID, and the second variable is our target variable, diagnosis, and it includes two levels. The B stands for the benign, and IM stands for malignant. So the rest 30 variables, we will all use them as the predictors, and they are all numeric variables. And well, there are the features used for the diagnosis of breast cancer. And because the first variable is ID and we do not need the patient's ID as one of our predictors, so we will drop this ID feature by using the -1. So it will only leave us 31 variables. You can see here 31 variables. And next we want to check the distribution of our target variable diagnosis. We want to see if it is equally distributed or it is a skew, it is unbalanced data. So you can see basically it is balanced. So we have 357 patients that do not have breast cancer, but more than 200 patients actually have the breast cancer. Well, you can also use the prop.table function to get the proportion, the percentage of the distribution of this variable, this diagnosis. And you can see that 62.7% of patients do not have the breast cancer. And noted here we use a round function with digits equals to 1 to limit the digital place for this percentage to only 1. And because we have, besides the target variable, the rest 30 variables are numeric, so we can have all the sample statistics results for all the 30 variables. Well, next we will create the training and testing dataset from this breast cancer dataset. Well, we will use the from row 1 to row 469 to construct our training dataset, and the rest rows will compose our testing dataset. So here we didn't use any set seed or the create partition function, so it is not random. So we just cut between the rows to get our training and testing dataset. So now for our training dataset, we have 469 patients. So for the testing dataset, we include the rest 100 patients to compose our testing data. And next, we will use the IBK model to train this K nearest neighbor classification model. So the first thing is because this IBK model is from the RWCA package, so we need to first load the RWCA package, and also the R minor because we want to also use the metric function to do the evaluation. So we'll also load the R minor package. Well, next is like build this model. Like the K nearest neighbor model is a classification model is a lazy learning. So for the training step, it only stores the features and also class labels from the training instances. So the first parameter is the formula, which is we use the diagnosis as our target variable and the dot to like represent the rest 30 numeric variables, and the data we use the training data set to first train this train this model. And you can see here inside this control parameter we set the k equals to 50. So we want to find 50 nearest neighbors for the new instance from the testing dataset. And you can also see x equals to true. So we will explain this x later. So let's first run this line of R command, and then you can check the model by calling its name. So you can see here we said that we want k equals to 50, which is 50 nearest neighbor. But this model only used 12 nearest neighbors. That is because we set x equals to true. So when you set x equals to true, you will this model will select the number of nearest neighbors between 1 and the k value, which is 50 in our case, to using the cross-validation evaluation on the training dataset and select the best performance model. So here we have 12 nearest neighbors, which means, well, when k equals to 12, we will have the best performance model. And let's see the summary of this model. So because this KNN, like I said before, is a lazy learning. So basically the training step is supposed to be like storing the training datasets, features, and class labels for each instance. However, here we can see we got a confusion matrix based on this training dataset. Basically, it means they also evaluate this model using the training dataset as a testing dataset. For example, for one training instance, they hide the class label for this training instances, and they find 12 nearest neighbors for this training dataset, training instance. And then based on the majority voting, they will decide, well, what the class label should be for this training instance. And then for the evaluation, they will evaluate the prediction for each training instance. So that's why we got this confusion matrix, and that's how they using the cross-validation evaluation on the training dataset to decide the best k value when you set the x equals to true. And if I do not want x equals to true, which means I want exact k equals to 50, so I will comment this, and here we will exclude the x equals to true parameter. So here we only have k equals to 50. And let's run this model again and see how many nearest neighbors for this classification model. So we only have we specify 50, so now we got 50 nearest neighbors for this classification. And next, let's see the summary. So see here, we got accuracy equals to more than 95%. Well, here you see, if we only use 12 nearest neighbors, we will reach more than 97% of accuracy. So that's why they choose 12 instead of 50 when you use x equals to true option. Well, next, because we have this model from our Weka package, so we can use this evaluate Weka classifier function. So this is the model. This is the testing data set we want to predict. And number false equals to 0, which means we do not do any false of cross-validation. We only want to evaluate and predict the instances from this testing dataset and also evaluate the performance for this testing dataset. So let's run this line. Well, you can see it performed pretty good because accuracy is 96% when we use. So this model now is using 50 nearest neighbors. So this confusion matrix is based on a testing dataset. And well, besides using the evaluate Weka classifier function, which will generate the predictions and evaluations together, we can separate them into two steps also. Like here we can also use predict to get the class label predictions for the testing datasets, and also use the add-matrix function to have the evaluations matrix for the prediction results for testing datasets. So let's run these two lines again, and so we will get the accuracy, precision, recall, F measures, and so on. So you can see this precision 1 is for the class B, and this precision 2 is for the class M. And this is results from the k nearest neighbor algorithm. You can also try using decision tree, like support vector machine, artificial neural networks, and so on, to see which algorithm performs the best. And next, we will go to another data set called the income. We used income for many algorithm right now. The support decision tree, support vector machine, and also the KNN models. So let's first import this income data set. And let's see the structure. So you can if you can recall, this is a pretty big data set, including 32,000 or more than 32,000 observations. So in order to increase the execution time, we will also use this sample function to only choose 2,000 rows to speed up the execution time. So if you recall this sample function, the first parameter is from the total rows. So from the first row to the last row of this data set, and the second parameter is specify how many rows you want to include in this sample. And then we don't want any replacement, and we give a new name for this sample called income. And let's run this. So if you see the sample income now, you can see we only have 2,000 observations and still 12 variables. Well, remember to set seeds. We set seed equals to 500, so we'll have the random sample result each time. No, we have the consistent random result each time we run this R command. Well, we can also use the prop.table function to check the distribution of our target variable, which is the income variable, inside this sample income. And you can see that about 76% of the people from our sample have less or equal to 50K income, and only 24% of the people have more than 50K income. And well, next we will use our originally partition dataset approach to partition our training and testing dataset. Well, we use 50% of the instance to construct the training dataset, and the rest for 50% we further partition them into 25% and 25% to construct testing 1 and testing 2 datasets. Well, remember to load the caret well. Well, we already load this caret because we set seed when we do the sample function before. And we also, when we partition the training testing dataset, we also need to set seed. Well, here, these are the old way we used so many times already. So I will directly run this chunk. So you can see here, the distribution for testing data 1 and testing data 2 are the same. So basically, we did randomly select training and testing 1, testing 2. Well, next we will also use this IBK model to create this KNN classification model. And well, the first 2 packages you need to load is RWCA and RMiner. Well, here we specify k equals 20, so we want 20. We suggest 20 nearest neighbor for this KNN model. Well, here you can see we specify x equals to true, which means we will select from 1 to 20 and select the best k value for the best performance model. So let's run this one. So this income is our target variable, and we will use all the variables all the rest variables as our predictors, and the training data set is used to build this model. And let's see how many nearest neighbor do they have. So we specify 20. They choose 15 nearest neighbors. Well, if you exclude them, you don't include this x equals to true, which means the default value is x equals to false, you will have the exact 20 nearest neighbors. So you can set this parameter based on your need. And well, let's see the summary. So as we can see here, the accuracy for this KNN model performs on the training dataset is more than 84%, and this confusion matrix is also built on this training dataset. Well, the next step is using, well, you can use the evaluate WCA classifier to test, to predict the instance, to predict the class label for the instance in the testing dataset and evaluate performance all at once. Or you can separate the step by using predict and metric. So we will separate the steps to evaluate the performance on testing 1 and testing 2. So here are the evaluation metrics for testing dataset 1, testing dataset 2. So the accuracy for testing data 1 is 82.8%, and accuracy for testing data 2 is 83.4%. And if you are still wondering how we distinguish the precision 1, precision 2, the recall 1 and recall 2, how can we know which class is 1 and which class is 2? Well, you can check the class label for the first instance in the testing data 1 and 2. So here we check the first 6 rows from the testing data 1. So here you can see the first class label the class label for the first instance is less or equal to 50K. Therefore, the precision 1, this 1 is for the less or equal to 50K class, and 2 is for the larger 50K class. And so is the testing data 2. You can see here, well, the first instance has the class label less or equal to 50K, so the precision 1 is corresponding to the class less or equal to 50K. Well, next we want to do the cross-validation for the 2000 2000 rows. This samples you also using IBK. We also like specify the k equals to 50, but we set x equals to true. Therefore, we will select like the best k values for the better model performance. The rest parameters are the same. And let's see how many k values did we use. Okay, we used 26 nearest neighbors for this classification. Well, next we want to use like different faults of cross-validation. Well, before we used like two methods. First one is using the for loop and also using the list apply. Well, for the model from the RYCA, we do not need those complex steps. We can directly use the evaluate YCA classifier function. And we just need to specify the number of faults equals to, well, how many faults do you need? Well, we tried 3, 6, and 10. When you use the cross-validation using the evaluate VACA classifier function, one thing to note is, see here, this income is the whole data set, the sample data set. So unlike we only use the testing dataset before when we not doing the cross-validation. Here, when we do the cross-validation, the second parameter is the whole dataset. So let's run this chunk. Well, if you have more faults, the execution time will be longer. So the last one is 10-fold, and the middle one is 6-fold. The first one is 3-fold. So you can see the performances are similar, even though we change the fold from 3 to 10. Well, the next we will use the original dataset. You know that the original dataset is pretty large. It includes more than 32,000 instances. So while the steps are similar, we just do not use the sample function to only include 2,000 rows. Instead, we use all instances and partition them to 50%, 25%, 25% to training, testing 1 and testing 2. And next chunk is to build and evaluate the KNN classification model using this original dataset. Also use the IBK model from the RWECA package. Well, because we have a pretty large dataset, it may take a longer time to execute, to build the model, and also to evaluate the model. So here are the results when we used like 50% of the original dataset as the training dataset, and the 25% as testing 1, and another 25% as testing 2. It took me like 2 to 3 minutes to complete the model building and also the prediction and also the evaluation. So here you can see, even though we we change the sample to original data, the accuracy and other performances and other like uh, evaluation metrics, the values are similar. So which means the sample like 2000 rows represent the whole data set. Well, next is using the cross-validation. Well, here we only show you the threefold cross-validation. Well, because we use this original data set, so it will take a longer time to proceed. So let's run this chunk again. So after about 5 minutes, I've got the results from the threefold cross-validation. And you can see the accuracy is also around 83%. So if you want to run like 6-fold or 10-fold cross-validations, you probably need like more running time. Well, next we will go to the K nearest neighbor models for the K nearest neighbor for regression model. Well, we will also still use the dataset insurance, like the healthcare insurance expenses, that dataset to demonstrate how can we build a regression model based on the K nearest neighbor algorithm. And the first of all, let's import this dataset. So it's the insurance dataset. And if you recall, the target variable is the numeric variable, which is the healthcare expenses, and the rest 6 variables are considered as predictors. And well, it's similar to the K nearest neighbor classification model. Well, the training phase is also storing the feature values and class label values for the instance inside the training dataset. Well, it's a little different when it comes to testing dataset. Well, the first phase is still using the distance function to find the k nearest neighbors for each instance inside the testing dataset. Well, instead of majority voting for deciding the class label for the instance in the testing dataset, we will use the k nearest neighbor. Will use neighbor algorithm will like calculate the average target variable value from this k nearest neighbors, and then assign this average value of this target variable to this instance in this testing dataset. So let's see. First, we also like partition our dataset to like 1 training and 2 testing, 50%, 25 and 25%. And next, we will build the KNN regression model, also using this IBK model from our webcast. So we first need to load the 2 packages. And here you see this IBK model. The first parameter is still the formula. So this is the target variable, also called as dependent variable. So this dot represent the rest 6 predictors. And we use this training data set. And we also like specify we want 20 nearest neighbors, and x equals to true means, well, this model will decide itself like which, like from 1 to 20, which k value is best for in performance. And so let's run this one. So basically the training step is storing, but it also serves as a testing dataset to evaluate the performance on the training model. So we specified 12 nearest neighbors. However, we only used 5 nearest neighbors. So this is chosen by this chosen by this IBK model based on the cross validation. And Because this expense is a numeric variable, so we no longer use the confusion matrix, accuracy, precision, recall, F measures, and so on as our evaluation matrix. Now we turn back to correlation coefficient and another 4 error measures. And next we will use this model to calculate the average value of the nearest neighbors and assign this average value to the target variable inside inside both testing data sets. We change those evaluation matrix to these six error measures and correlation and also R square. The functions used to generate the prediction and also the evaluation are the same, which are prediction function and also metric function. So let's run these 4 lines of our comments. Also you can use this evaluate YCAR classifier. When you use this one, you can recall that we do not need this predict anymore. It will generate the prediction and evaluation altogether. Next, similarly, we can also use the cross-validation to evaluate the IBK regression model performance. Here, when we build this K-nearest neighbor model using IBK for cross-validation, remember to use the whole dataset instead of only the training dataset. And also here, for the evaluate YCAR classifier function, remember to put the whole dataset name instead of training dataset, or instead of testing dataset name in the second parameter. And we demonstrate with 3-fold, 6-fold, and 10-fold. So let's run this chunk. So you can see these are 6-fold, 10-fold, and 3-fold. We don't see large differences among these 3 different cross-validation faults. So basically, that is what we covered in this tutorial. And thank you for listening, and thank you for your patience. Bye.